Imagine boarding a train in the center of a city and just a short time later, arriving hundreds of kilometers away. Now imagine the train traveling at 600 kilometers per hour. That sounds like science fiction, but China has been working on technology designed to make this kind of speed possible. Before we explore how this incredible train works, make sure you subscribe to RailForge and turn on notifications. Here, we explore the world's most fascinating trains, railway technology, and engineering projects. Now let's get into it. China already has the largest high-speed railway network in the world. Its trains regularly operate at speeds of around 300 to 350 kilometers per hour, connecting some of the country's biggest cities. But China isn't stopping there. Engineers have been developing a new generation of magnetic levitation, or Maglev, trains that could potentially reach speeds of up to 600 kilometers per hour. So what makes this train different? A conventional train uses steel wheels that physically contact steel rails. That contact creates friction. A Maglev train works differently. Instead of relying entirely on wheels, magnetic forces can lift the train slightly above its guideway. Other magnetic systems then help propel the train forward. With no conventional wheel-to-rail contact during high-speed operation, some mechanical friction can be significantly reduced. And this allows the train to reach extraordinary speeds. But reaching 600 kilometers per hour isn't simply a matter of adding a more powerful motor. At these speeds, even the air becomes a major obstacle. As the train accelerates, aerodynamic drag increases dramatically. This means engineers have to design the entire train around airflow. The nose has to be extremely aerodynamic. The body needs to reduce turbulence, and the guideway has to be built with extraordinary precision. At 600 kilometers per hour, the train would travel around 167 meters every second. In just 10 seconds, it could cover more than 1.6 kilometers. That means even tiny engineering imperfections can become important. The train's control systems also have to constantly monitor speed, position, power, and other operating conditions. But why does China want to build a train this fast? One major reason is competition with air travel. Flying between two cities may look faster on paper, but air travel involves much more than the time spent in the air. Passengers have to reach the airport, arrive early past security, wait for boarding, and then travel from the destination airport into the city. A very fast railway can potentially connect city centers directly. For journeys of several hundred kilometers, that could make ultra-high-speed trains extremely competitive with airplanes. China also has another advantage. The country already has enormous experience building high-speed railway infrastructure. Thousands of kilometers of high-speed rail lines have transformed domestic transportation. This existing railway industry gives China a strong foundation for developing the next generation of rail technology. But there is a major difference between demonstrating a train at extremely high speed and operating one as a normal passenger service. Building a 600 km/h Maglev network would be incredibly expensive. Entirely new guideways would be required. Stations would need specialized infrastructure. Maintenance would require advanced equipment and highly trained workers. And the electricity requirements could also be enormous. There is another challenge that many people don't consider. Speed isn't everything. If a train takes years to build, costs far more than an airplane ticket, and requires completely separate infrastructure, passengers may not choose it simply because it is faster. So the real question isn't just, can the train reach 600 kilometers per hour? The real question is, can it do it safely, reliably, and economically? That's the challenge engineers and planners have to solve. And if they succeed, the impact could be huge. Imagine a future where major cities are connected by trains traveling hundreds of kilometers per hour faster than today's conventional high-speed rail. Instead of flying between nearby cities, millions of passengers could potentially choose ultra-high-speed rail. There would be no long runway, no aircraft turbulence, and potentially no airport transfer at either end of the journey. Just a high-speed train connecting city centers. But Maglev technology isn't new. Japan has also been developing its own high-speed Maglev system, with ambitious plans for future passenger services. China and Japan are therefore part of a much larger race to develop the next generation of rail transportation. The technology could eventually change the definition of what a train is capable of. For more than a century, railways have been based around wheels, tracks, and locomotives. Maglev challenges that traditional design. Instead of pushing wheels along rails, magnetic forces can lift and propel the vehicle. And that opens the door to speeds that conventional railways struggle to reach. However, we shouldn't expect every railway in the world to suddenly switch to 600 km/h Maglev. For many routes, conventional high-speed rail may remain the better option. It is already proven, efficient, and compatible with large existing networks. Maglev could make the most sense on specific high-demand corridors where speed can justify the enormous investment. And that's what makes China's 600 km/h project so interesting. It isn't simply about breaking a speed record. It's about asking a much bigger question. What if the train of the future doesn't need wheels to travel at extreme speeds? What if a journey that currently requires an airplane could one day be completed by a train traveling silently through a magnetic guideway? We aren't there yet. There are still huge technical, financial, and infrastructure challenges. But China has already demonstrated that it can build railway systems on a scale that was once considered impossible. The next step is proving that ultra-high-speed Maglev can become practical for everyday passengers. If that happens, the railway industry could enter a completely new era. A train traveling at 600 km/h would not just be another faster train. It could be the beginning of a new way of traveling between cities. So would you choose a 600 km/h Maglev train over an airplane? Let us know in the comments. And if you enjoyed this video, subscribe to RailForge and turn on notifications for more incredible trains, railway technology, and engineering stories from around the world. Thanks for watching, and I'll see you in the next one.